An electric motor is an electrical machine that converts electrical energy into mechanical energy. Most electric motors operate through the interaction between an electric motor's magnetic field and winding currents to generate force. So, electric motors can generate boats, cars, or any other vehicle or man-made appliances in the world. For our electric motor, we're going to need a couple of paper clips, coiled wire, a rubber band, a battery, a magnet, and some sandpaper. The paper clips will act as our conductors, which will complete the flow of electric current throughout the system. The coiled wire will be the main source of our motor, which will spin around, generating electric power. Our rubber band will keep our paper clips and the battery together, while also acting as an insulator. The battery will be our main power source for the motor. The magnet will repel and attract the coiled wire, which will cause it to spin, and the sandpaper will be used to scrub the edges of the coiled wire to get rid of the insulation.
A magnet has two poles, a north pole and a south pole. Opposite poles attract and like poles repel. The magnets create fields. In the magnetic field, the field moves from the north pole to the south pole. The field around the coil is only present when the circuit is completed and the coil becomes an electromagnet, which means only when the shaved side of the coil is touching the paperclip. It is very important for the field to turn on and off because if it was always on, the coil would just stick to the magnet, and if it was always off, the coil would never move. Gravitational and normal forces are acting in the coil all the time, no matter if it's on or off, but a magnetic force only acts upon it when it is on. The magnetic field pulls one side of the coil down while pulling the other up. When the magnet is about to connect to the coil is turned off and the centrifugal force makes it continue spinning. It then gets turned back on and the process starts anew.
And that will be the end of the film.